Hello everybody, I know you're writing Maths Paper 1 tomorrow and I worked through this question on my live yesterday. I thought that I would put it on my account as well so that you can access it easily. This is a counting principle question. This is from last year. This is the last question in the November 2022 Paper 1 exam, and they are saying that a 4-digit code is required to open a combination lock. Now as soon as I see that it's a 4-digit code, I'm going to draw 4 lines. Each line represents 1 digit in that code. Now they're giving us a number of restrictions here. The first thing that they're saying is that the code must be even numbered. Now when they say that, they mean that the code as a whole, right? If you have the number 12, for example, that is an even number. If you have the number 17, that's not an even number. 12 is an even number because it ends, the last digit of that number is even. 17 is an odd number because the last digit of that number is odd. What the first digit is, whether it's even or odd, I'm referring to the 1 here, does not actually affect the number as a whole. The whole number is even when the final digit is an even number. So when they're saying that the code must be even numbered, that means that the last digit must be even. Now, the next restriction that they're giving us is that this code may not contain the digits 0 or 1. That's important. And then the last restriction is that digits may not be repeated. So for 10.2.1, they're asking us how many possible 4-digit combinations are there to open the lock. So what we need to now think, you need to take into consideration the restrictions first. Now they told us that this code may not contain the digits 0 or 1. So that means that we can only choose between 2, 3, 4, 5, 6, 7, 8, and 9. There are 8 possible numbers that we could use in this code. So 8 options for numbers that we could use in this code. We may not use 0 or 1. Now the fact that they're saying that this must be an even number means that the last digit of this number must either be a 2 or a 4 or a 6 or an 8. So how many even numbers are there? How many options do I have? How many possible numbers could there be in the last digit of this code? 4. So what I write on these lines is I write the possible options, the possible number of digits that you could use in that space. Now after that, since we have now put a number in the last slot, let's say it was 2, we now may not use that same number again. It actually doesn't matter whether it was a 2 or a 4 or a 6 or an 8. The bottom line is we now no longer have 8 options for a different digit in this code. We now only have 7 options. Once we've put a number in that first slot, we now have already used 1, 2 of our 8 options. We now only have 6 options left. That is now 3 numbers that we've used. So now we only have 5 options left for that last number. So the number of possible 4-digit combinations that there could be to open the lock is 7 times 6 times 5 times 4. That is 840 codes.